What is electromigration in electronics? Imagine tiny metal atoms in a circuit slowly drifting away over time because of the electric current flowing through them. That's what electromigration is all about. It's a process where metal atoms inside tiny wires or connections move gradually due to the force of electrons passing through. When electric current flows, it creates a kind of push called the electron wind. This wind pushes atoms along the direction of current flow, causing them to migrate. Over time, this movement can cause serious problems in electronic devices. In real-world cases, electromigration can lead to failures in electronic components. For example, in integrated circuits, the tiny metal lines that connect different parts of a chip can thin out or develop voids. These voids are empty spaces where atoms have moved away, weakening the connection. When these voids grow large enough, they can cause open circuits, stopping the device from working. Conversely, atoms can also gather in certain spots, forming hillocks or bumps that might cause short circuits by bridging to lines. Both of these issues can make a device stop functioning or even cause it to fail suddenly. Electromigration mainly affects the metal interconnects in chips and electronic packages. As technology advances, the metal lines become thinner and carry higher current densities. This makes electromigration more of a concern, especially at the package level, where solder joints and redistribution layers are involved. These tiny solder connections can crack or develop voids because of atom movement, leading to connection failures. Such failures can happen after months or even years of normal use, making electromigration a silent but dangerous problem. The forces behind electromigration involve two main factors. One is the electric field that pushes ions, but the stronger force is the momentum transfer from electrons to metal atoms. This is called the electron wind. It's especially active at grain boundaries and interfaces within the metal, where atoms are less tightly bound and more prone to move. Metals like aluminum and copper behave differently under electromigration. Aluminum tends to migrate along grain boundaries, while copper can move on surfaces or at grain boundaries. The severity depends on factors like the size of the metal lines, the amount of current, and the temperature. Higher temperatures speed up atom movement, making failures more likely. From a product failure perspective, electromigration is a major cause of mechanical breakdowns in electronic devices. It causes the metal connections to weaken gradually, which can lead to sudden failures. Engineers design circuits with wider and thicker metal lines to handle higher currents and reduce electromigration risks. They also choose materials less prone to atom migration and control operating temperatures. Reliability models help predict how long a device will last before electromigration causes failure, guiding better design choices. In summary, electromigration is a slow but persistent movement of metal atoms caused by electrical current. It can cause open circuits, short circuits, and ultimately device failure. Understanding this process helps engineers build more reliable electronics, especially as devices become smaller and more powerful. Managing electromigration is key to ensuring your gadgets keep working smoothly over time.